So what is the basic architecture of Spark? So here's kind of a simplified diagram, and it illustrates the three main players in any Spark cluster. The first one is the Spark driver. So the driver in this picture is the green box on the left. The driver is a JVM or Java virtual machine, and the driver is the brains of the whole operation. The driver is the thing that understands your code and your queries. It does all of the scheduling and planning. It does the recovery when there are problems. So your driver is really the brains, and it's just one of those. And it plans all of the work. The next big player are the executors. These are the pink boxes over on the right. Executors are also JVMs or Java virtual machines. And the executors are meant to be dumb and simple and inexpensive. So we can have lots and lots of executors. So when we talk about a 1,000 node Spark cluster, what we really mean is 1,000 executors. And the executors are meant to accept work from the driver and do it. So the executors just do three things. They run tasks that they're told to run by the driver. They can cache data or store it either locally on their node or like on disk or in memory. And they can also trade blocks of data with the other executors in order to do certain operations. So in the data parallel programming paradigm, we have our map operations and our reduce operations. If you're not familiar with that terminology, that's fine. But reduce operations refer to operations where in order to get a final answer, we need some data to move around the cluster. So you could imagine in our example of customers from New Jersey, if we wanted to total up all of the revenue from those customers, right? We could total up the revenue from the New Jersey customers on each executor. But in order to get a grand total for our final report, we need to move those totals together and kind of get a sum across the whole cluster. That's kind of a simple way to think about it. And the executors handle that on their own. The third player here is the cluster manager. That's the blue box in the middle. And the cluster manager doesn't do a whole lot with Spark. The cluster manager is mainly there in order to help Spark's driver start up and acquire executors. And in case executors die, or if we're running in auto-scaling mode and we want more executors, the cluster manager helps us acquire additional executors. There's several different cluster managers you can use with Spark, and in some of the longer courses, we get into the details of that. So I have a summary here. This notebook will be available. I'll make it available after the seminar here today, and so you can take a look at some of those details. This kind of sums up what we were talking about, and it lists the available clustering options today. So you can refer back to that. In terms of programming Spark, there are lots of ways to do it. If you download Spark, it comes with an interactive shell in Python, Scala, R, and SQL. You can write scripts. You can also compile programs like Java or Scala programs into regular old jar files and launch those on Spark using a helper called Spark Submit. You can write your code in various languages. Spark has support for SQL, Scala, Python, R, and Java built in. And there are extension projects on the net that allow you to use .NET tools like C# and F#, or even JavaScript if you wanted to. But mainly it's Scala, SQL, Python, and R. Those are probably the predominant ones, and then maybe Java a little bit behind there. And today we'll be using Scala, SQL, and a little bit of Python as well. So let's take a